All right, here are solutions for quiz 4. This first problem has 4 different parts, each of them asking to evaluate some log. And I think what you'll see is you need to use your log rules to evaluate these logs. So like this first one, for example, the log base 2 of 8 to the 50th power. You're like, I have no idea because I don't know what 8 to the 50th power is. I'm like, don't worry, you don't need to know what 8 to the 50th power is. We can use our third log rule to bring this 50 down in front, and then it's just 50 times the log base 2 of 8. And the log base 2 of 8 is just asking you the question, what power do you got to raise 2 up to make it equal to 8? And the answer to that is 3. So we get 50 times 3. In other words, 150 is the log base 2 of 8 to the 50th power. The second one here, 2 times the log base 6 of 3 plus the log base 6 of 4. Problem, I don't know the log base 6 of 3. And for that matter, I don't know the log base 6 of 4. Solution, use your log rules. First, you might notice this plus here and think you should use your first log rule, but you can't as long as you have this coefficient. So first we'll take care of this coefficient by using our third log rule and rewriting this as the log base 6 of 3 squared plus the log base 6 of 4. And then if you recognize that 3 squared is just 9, then this is just the log base 6 of 9 plus the log base 6 of 4. And I still don't have logs that I can evaluate, but now I can use my first log rule to rewrite this as the log base 6 of whatever 9 times 4 is equal to. Well, 9 times 4 is 36. I kind of feel like we may have seen this example already in this class. The log base 6 of 36 is just equal to 2 because 6 to the second power is equal to 36. So this answer is just 2. What about this third one? Well, here, maybe you notice that we're subtracting these two logs. So you're thinking, oh, I should use my second log rule. And that's entirely right. This is the log base 4 of whatever 3 divided by 12 is equal to. Well, 3 divided by 12, that fraction reduces to just 1/4. So if we could figure out the log base 4 of 1/4, we'd be done. The log base 4 of 1/4 is -1 because this 4 to the -1 power is equal to 1/4. And then finally, part D here, 1,000 raised up to the log of 5. I don't know what the log of 5 is equal to, but again, it's not going to matter. If you recognize that this is the log base 10, then our little trick is we want to write the base of the exponent and the base of the log to be the same number. 1,000 is 10 to the third power, so I can rewrite this as 10 to the third power raised up to the log base 10 of 5. Now my third exponent rule tells me that when I'm raising exponents up to exponents, I can multiply together those two exponents and get 10 raised up to the 3 times log base 5 power. If it weren't for this 3, I'd be in great shape because the base on my exponent would be the same as the base on my log. But I do have this 3 here, so I'm going to take care of this 3 by moving it up into the exponent using my third log rule, and I get 10 raised up to the power of the log base 10 of 5 to the third power. Now this 10 and this log base 10 cancel out, and so I'm left with is just 5 to the third power, which ends up being 125, because 5 times 5 is 25, and 5 times 25, think 5 quarters, gives you $1.25. At any rate, the answer is 125. What about on the second page of the quiz? Well, second page of the quiz, we're solving equations, although I think you'll see to solve some of these equations, it's beneficial to use your log rules. This first one, I don't think you need to use any log rules at all. To get to this x, I got to get rid of this log, but it's easier to get rid of this log if this 2 isn't here. So maybe I can start out by dividing both sides of the equation by 2, and then I get the log of x plus 1 is equal to 2. And now you could think about this as I'm just rewriting it in exponential form, but I'm going to write the intermediate step just because I think it helps to think about it that way. If the log of x plus 1 equals 2, then 10 raised up to the log of x plus 1 equals 10 raised up to 2. The advantage to this form, even though it looks uglier than this form, is the 10 and the log base 10 cancel out. So I'm left with just x plus 1 is equal to whatever 10 squared is, and 10 squared is 100. So x plus 1 is 100, and therefore x is equal to 99. This second one is not a log equation, it's an exponential equation, but will involve logs to solve it. I want to get at this x, so I'm going to have to take a log of both sides of the equation. It'll be easier to do so if this 3 weren't here, so maybe I'll start out by dividing both sides of the equation by 3, and that'll leave me with 2 raised up to the x minus 2 power on the left side. And on the right side, well, I guess I would have 3 quarters divided by 3, which is kind of ugly. So maybe instead of thinking about dividing both sides of the equation by 3, I'll think about multiplying both sides of the equation by 1/3. That still cancels out this 3, and now I get 1/3 times 3 quarters, which simplifies a lot nicer. I can cancel out these 3's and just get 1/4. You might be able to look at this and tell what my exponent must be equal to in this case, but I'm going to take you through the steps that I kind of advised you to do in the video. What I would do at this stage is, all right, I want to get at this x, so I better take a log of both sides of the equation. Which log? Well, any log will do, but the log base 2 will work out the nicest. So I'm going to take the log base 2 of both sides of the equation. The log base 2 of 2 to the x minus 2 power must be the log base 2 of 1/4. And the nice thing about this is the log base 2 of 2 to the x minus 2 power, the log base 2 and this base of the exponent of 2 informally cancel out, and we're left with just x minus 2 on the left side. And the log base 2 of negative 4, well, that's equal to negative 2 because 2 to the negative 2 power is a fourth. The negative puts the 2 down in the denominator, and 2 squared gives me the 4. So I got x minus 2 equals negative 2. So if I add 2 to both sides of the equation, I get x equals 0. You're like, oh, I must have messed up. It can't possibly be x equals 0. Yeah, it is. Try throwing a 0 in here. 2 to the negative 2 power is just a fourth. And 3 times a fourth is just 3/4. The answer is x equals 0. Finally, this last one, 9 to the 2x minus 3 equals 27 to the x plus 1. My variables are up in the exponent. There's 2 of them, so that'll make this a little bit more challenging. To get the variables out of the exponent, I'm going to have to take a log of both sides of the equation. Which log? Well, frankly, lots will work. Log base 9 would be fine. That'll make the left side really nice, although the right side won't be quite as nice. Log base 27 would be okay. It would make the right great, although the 9 wouldn't be as great. If you want to just use log or natural log or something, you can do that as well. But I think what will make this clean up the nicest is taking the log base 3 of both sides of the equation. And that's because 3 raised up to the second power is 9 and 3 to the third power is 27. So it's going to simplify really nice. What I'm saying is if 9 to the 2x minus 3 equals 27 to the x plus 1, then the log base 3 of 9 to the 2x minus 3 must be equal to the log base 3 of 27 to the x plus 1 power. By introducing these logs, I can now use my third log rule, which will work out really nicely. This 2x minus 3 can come out of the exponent and become the coefficient on the log base 3 of 9. Similarly, over here, the x plus 1 can come out of the exponent and become a coefficient now on the log base 3 of 27. Be careful, make sure you have the parentheses on each of these. Otherwise, it's just the negative 3 that's getting multiplied by this guy. But really, the entire exponent should get multiplied by this guy. And then by choosing log base 3, these are going to work out really nice. The log base 3 of 9 is just equal to 2. So I get 2x minus 3 times 2 on the left side. And the log base 3 of 27 is 3. So I get x plus 1 times 3 on the right side. And the justification for those is 3 to the second power equals 9, and 3 to the third power equals 27. Now I just have a linear equation, easy enough to solve. Distribute the 2 through to get 4x minus 6. Distribute the 3 through to get 3x plus 3. And then get all your x's on one side, so subtract 3x from both sides. That leaves me with just an x over here. And then add 6 to both sides, and that gives me a 9 over here. X equals 9 is the solution to this last log equation. Or maybe I should call it an exponential equation that I had to introduce logs for. And that ends the quiz.